Welcome to The Explainer. Today, we're diving into something really cool. What happens when AI stops being this one single superbrain and starts acting like a team?
So, what if AI wasn't this single, all-powerful supermind, but a whole crew of specialists? That's the idea we're exploring today. We're kind of stepping away from that classic sci-fi image of one giant, all-knowing AI, and we're jumping headfirst into the real-world concept of AI teams. These are groups of specialized programs that work together to solve problems that are just way too big for any one mind to handle on its own.
Okay, so to really get how these AI teams function, we got to start with the basics, right? We need to understand the individual player on the team. And that's the intelligent agent. It's really the fundamental building block for all of this.
So what exactly is an agent? Well, the easiest way to think about it is like a little digital problem solver. But it's not just some passive piece of code. Nope, it's built to have a degree of independence. It's always running through this cycle. It looks at its environment, it perceives, then it thinks about what to do. It reasons, and then it takes an action to get closer to its goal.
Right, and these four properties are what really make an agent, well, intelligent. You've got autonomy, like a self-driving car handling traffic all by itself. Reactivity, think of a smart thermostat kicking on when the room gets cold. Proactivity, that's like your AI assistant pinging you about a meeting you forgot. But that last one, social ability, that's the key. That is the absolute game changer. It's the secret sauce that lets a single agent join up and become part of a seriously powerful team.
So if one agent is a single player, what happens when you build an entire team? Well, that's exactly where we get into what are called multi-agent systems, or MAS for short. And you might be asking, okay, but why? Why team up? What's the advantage of a team over just one super smart agent?
And it really boils down to this simple comparison. Are you looking for a generalist, or do you need a team of specialists? A single-agent system is kind of like that solo freelancer, a jack-of-all-trades who tries to do everything. But a multi-agent system, that's like a full-on project team. You've got multiple members, each with their own unique skills, all working together to tackle much, much bigger challenges.
And when you put them side by side like this, the advantages just pop. I mean, look at robustness. If your one and only agent goes down, your whole system fails. Poof, gone. But in a team, if one agent fails, others can often pick up the slack. There's built-in fault tolerance. And scalability? With a single agent, you're limited. But with a team, you just add more agents. This makes them a perfect fit for the messy, complex, distributed problems we see in the real world.
Okay, so you've got this team of agents. How do they actually work together without just creating digital chaos? It all comes down to two really important ideas: coordination and cooperation. Now, they might sound like the same thing, but in this world, they are critically different. First up, coordination. Think of this as just avoiding chaos. It's about managing traffic. The perfect example is a bunch of self-driving cars coming to an intersection. Each car has its own goal, right? A totally different destination. But they all follow the rules of the road, they manage their interdependence, so they can all get where they're going without a massive pileup.
Now, if coordination is just about not crashing into each other, cooperation is true teamwork. This is where things get really interesting. Here, agents are actively working together toward a single shared objective. So instead of cars in an intersection, imagine a team of rescue robots after a disaster. They're sharing information, they're helping each other, they are all laser-focused on one mission: finding survivors.
So when you look at them like this, the big difference really jumps out. It's all about the goals. For coordination, the agents can have completely different, even conflicting goals. But for cooperation, they must have a shared, common goal. And here's the takeaway. You can totally have coordination without cooperation, but you can't have good cooperation without coordination. You got to know how to not step on each other's toes before you can work on a project together.
All right, so this all sounds great in theory, but how does it actually work? How do agents decide who does what task? Let's dive into one of the key mechanisms that makes all this organized teamwork possible. One of the most elegant solutions out there is something called the Contract Net Protocol. And honestly, it works just like a little marketplace for getting tasks done. You have one agent, let's call it the manager, that has a job it needs done. So it broadcasts a call for proposals.
Then other agents who think they can do the job, the contractors, they submit bids. The manager agent looks at all the bids, picks the best one, and awards the contract. That chosen agent then gets the job done and reports back. It's a really clever and decentralized way to distribute work.
When it comes to the overall strategy, the planning itself can happen in a couple of ways. You can have centralized planning, which is very top-down. Think of a single supervisor agent that creates the master plan for everybody else, classic hierarchy. Or you can have distributed planning. This is more of a bottom-up approach, where the agents themselves collaborate, each creating part of the plan and then merging them all together into one cohesive strategy.
So I know a lot of this might sound a bit abstract, a bit theoretical, but why does any of this matter to you? Well, here's the thing. You are already interacting with and benefiting from these AI teams right now. They are out there in the real world tackling some seriously huge and complex challenges.
I mean, just think about it. Coordinated drone fleets, whether for deliveries or surveillance, that's a multi-agent system. Social simulations that model how crowds might behave in an emergency, that's a mass. They're all over e-commerce and finance, doing things like automated trading or spotting fraud. They're even helping manage our power grids to optimize energy distribution and coordinating massive global supply chains. These are not future tech concepts. They're here.
But, and this is a big but, building these systems is not easy. Not at all. There are some massive challenges. For one, scalability. Sometimes when you add more and more agents, performance can actually get worse. Then there's complexity. You get these emergent behaviors that can be totally unpredictable and a nightmare to debug. And then you get to the really tough stuff, trust and security. How do you protect the team from a rogue or malicious agent? And maybe the biggest question of them all, ethics. How in the world do we encode human values into a team of autonomous agents?
Now, the next frontier, the thing that has everyone really excited, is combining these agent teams with the power of large language models, or LLMs. Just imagine, every single agent on the team having his own advanced brain, capable of really sophisticated reasoning, planning, and communicating just like we do.
And that brings us to what is probably the single most crucial question in all of this. As we build these AI teams, and we make them more powerful, more autonomous, as we give each agent its own mind, how do we guarantee that they work for us and not just with each other? Ensuring that a team of super-intelligent agents stays aligned with human goals, well, that's not just a technical problem. It's the ultimate challenge for the future of this entire field.